work. So this is Monday. We're still working with functions. We're going to be starting putting together how the function works. So a couple things I want to bring attention to. One, reviewing from last week. This is just our notes from last week, just as it states, including the steps. And if you notice, step 4 has changed. So we're going to write the coordinate, and that is using our information of the x, y. So our coordinate is x, comma, y. That's the name of a point. Oops, arrow point. So the x is given. So if you look at step 1, we see the x equals 1. So the x is always going to be given, and we're solving for the y, because remembering that y equals f of x, or f of x is the same thing as y, and that is what we solve for. So in this case, we had 1. So again, the 1 was given to us, and then we did all that work on the right-hand side to find out what the f of 1 is, so the function of the 1, or the y to this x, and this is what it was, 1 equals 3. So let's go through our notes, because that's really what it's talking about. So x, y is a coordinate pair, or point of a line. The x is the input, the y is the output, and the other name for this, for the y, is f of x. So when we're using the input to make the output, we think of it as a function machine, or a function equation machine. And the rule is the equation. So whatever you put in, something spits out. So in this case, we put the 1 in to this machine, the 2x plus 1, and it spit out a 3. So that's how we use the function. Again, the rule is the function equation. So there is an analogy for this, the function machine, and there's a video that some other teacher provided, and I like it a lot. So for the directions today, you're just going to be substituting the x, solving on the right like you have been, and then naming the coordinate using exactly what I did up here. So I'm going to do it with you for 1, 2, 3. Did I have 3 3s? I have 3 3s. The 2 3s, excuse me. So 4 of them. So we're going to start with the substitution. So we have f of 1 equals 2 times the 1 in parentheses to preserve the multiplication. Now we're just going to solve for that answer. You should be using your calculator at this point. So I'm going to skip those steps. 2 times 1 is 1. 2 times 1 is 2 plus 1 equals 3. And then my coordinate point must be 1, comma 3. Looking at f of x equals 2x plus 1, this time x equals 2. And again, we're using that same rule because we're going to be putting this together and talk about how it looks when we graph. So the first thing we do is substitute. So f of 2 equals 2 times 2 plus 1. Oops, I wrote equals 1. That was not right. Next step is going to be simplify. Using your calculator, you'll know that 2 times 2 equals 4. 4 plus 1 equals 5. Naming that point now, it's 2 because x equals 2, comma 5. Number 3, f of x equals 2x plus 1. This time x equals 3. So f of 3 equals, substituting 2 times 3 plus the 1. Remembering the parentheses, it gives us the multiplication. F of 3 equals 2 times 3 is 6 plus 1 equals 7. So this time the x equals 3, so I have x equals 3, and I solve for the 7. That's my coordinate pair. The number 4, which on your paper is going to accidentally be, I just realized I didn't make a copy of this. It's okay. So f of negative 5 equals 2, negative 5. Remember to keep that negative. This one was a challenge one. So we have f of negative 5, negative 5 equals 2 times negative 5 equals negative 10. I'm going to do this one out because it's a little harder to remember. So I'm going to do my next step just to show you guys the math with our integer rules. Again, you should be using the calculator. So you have negative 10 plus a positive 1. So that equals a negative 9 if you remember what our number line looks like. Negative 5, negative 9. And there you have it. So all we're working on today is using our function, our rule, and it's the same rule the entire time. Our rule is 2x plus 1. Whatever we put in as the x, we'll get the out, and we're just putting it into that coordinate pair. I look forward to seeing your work.